Shanghai Hongqiao International Airport, China, April 6, 1993. 255 souls board Flight 83, a blend of 235 passengers and 20 crew members. Their journey stretches from Beijing to Shanghai, then onward across the vast expanse of the Pacific Ocean, destined for Los Angeles. The first leg of this intercontinental voyage unfolds without incident, the aircraft slicing through the air with quiet efficiency. Ahead lies a grueling passage over the endless ocean, a test of magic. This flight is entrusted to a marvel of aviation engineering, the McDonnell Douglas MD-11. Born from the lineage of the iconic DC-10, the MD-11 emerged in 1990 as a profound evolution, promising extended range and a leap into the digital age. Its cockpit, transformed into a glass cockpit, replaced the analog dials with luminous screens, allowing the removal of the flight engineer's station and reducing the cockpit crew to 2. Wings, adorned with graceful winglets, stretch outward to tame the air and enhance fuel efficiency, while a truncated tail assembly redefines stability. Engineers shifted the aircraft's center of gravity rearward, a subtle yet significant alteration that sharpened maneuverability but demanded unwavering precision from its pilots. At the heart of its flight control lay the longitudinal stability augmentation system, a precursor to the sophisticated fly-by-wire technologies seen decades later. Constantly nudging the control column, it steadied the aircraft's nose, making the MD-11 one of the earliest airliners where electronic systems played an indispensable role in maintaining flight stability. The aircraft bearing registration Brava 2171 belonged to the Far East Airlines of China. Delivered in May of 1991, it had logged a mere 4,810 flight hours, still in the infancy of its operational life. Its fuselage gleamed with factory paint, seats wrapped in pristine upholstery, and its avionics represented the cutting edge of their time. As ground crews loaded luggage with practiced efficiency, the cockpit remained a sanctuary of focus. In the right seat sat Captain Liu Jiangping, aged 42, a pilot molded by tradition, yet embracing modernity. He had amassed 8,535 flight hours, with 1,341 of those spent mastering the MD-11's demanding controls. Yet he occupied the right seat, a position atypical for a captain, because here he assumed the role of instructor, guiding his co-pilot through the intricacies of this exacting aircraft. Alongside them was the seasoned flight engineer Lu Yangxin, charged with overseeing the complex systems that sustained the flight. Every detail, every calculation, every decision bore the weight of responsibility. This was no ordinary journey. It was a delicate dance between human skill and technological innovation, poised on the edge of the vast Pacific, where the slightest misstep could ripple into catastrophe. The MD-11, with all its promise and complexity, awaited the command of those who dared to master it. The heart of the operation rested in the vigilant monitoring of this airborne computer's flawless performance. Though the aircraft had long since shed the need for a flight engineer, many airlines still assigned one on extended journeys, a nod to tradition and caution. At precisely 17 hours and 55 minutes local time, the plane embraced its executive start. The air traffic controller granted clearance for takeoff, and the pilots unleashed the roaring power of 3 Pratt & Whitney engines, propelling the MD-11 into the sky above Shanghai's runway. The ascent was seamless, the aircraft climbing toward flight level 330, 10,000 meters above the Earth's surface. This altitude was no mere number. It was a meticulously defined corridor, measured by standard atmospheric pressure, a vital channel through which controllers orchestrated the ballet of countless aircraft. 5 hours into the journey over the vast Pacific, life aboard the plane quieted into a lull. Dinner had been served, and most passengers surrendered to sleep. The cabin crew, led by senior flight attendant Ivan Yapin, dimmed the main lights, inviting the weary travelers to lose themselves in the flicker of a movie. In the cockpit, calm reigned supreme, fed by the autopilot's impeccable precision. Yet, beneath this veneer of security lay a deceptive tranquility. It was this very illusion, the belief in the machine's infallibility, that dulled the crew's senses to the first subtle tremors of disaster. When the aircraft traversed the remote expanse of ocean, thousands of kilometers from the Alaskan coastline, the instruments began to betray an unsettling anomaly. Luzan Pin, seated as first officer, was the first to glimpse the irregularity on his primary flight display, an advanced digital screen replacing a dozen analog gauges, offering a transparent window into the aircraft's vital signs. Next to the indicator showing the aircraft's speed at 0.82 Mach, a second figure materialized, a ghostly circle displaying 0.72 Mach. To grasp the gravity of this, one must understand that Mach number is the ratio between the aircraft's speed and the speed of sound. At 10,000 meters, where the air is thin and frigid, 0.82 Mach represents the optimal balance between fuel efficiency and aerodynamic stability, allowing the colossal machine to slice through the sky with confident grace. The sudden appearance of a second, lower speed was a paradox. It suggested the onboard computer was perceiving a conflicting reality, one that should not exist. The crew's attention sharpened as they began diagnostics. Luzan Pin had never encountered such a phenomenon. The secondary speed indication was unprecedented. The pilots delved into the data, their minds racing against time and uncertainty, seeking the source of this electronic discord. This was no trivial glitch. It was a harbinger, whispering of a deeper fault lurking within the labyrinth of circuits and sensors that governed the flight. Each flicker on the screen, every inconsistent reading, chipped away at the illusion of control. The vast ocean beneath offered no refuge, the nearest shores hours away, a silent witness to the unfolding enigma. In this suspended moment where technology and human judgment intertwined, the fragile balance between trust and suspicion began to tilt. The aircraft's systems, designed for precision and reliability, now cast shadows of doubt. The pilots, guardians of lives and machines, stood at the threshold of an unfolding mystery, compelled to confront the unexpected and navigate the thin line separating routine from catastrophe. The journey had transformed, from a routine passage through the sky into a silent battle against the unseen forces within, a testament to the complexity woven into the very fabric of modern flight. The story of this flight reveals more than a mechanical anomaly. It exposes the intricate dance between man and machine, the fragile confidence placed in automation, and the subtle cracks that can appear beneath even the most polished surfaces. Each instrument, each indicator tells a story not only of speed and altitude, but of trust, perception, and the relentless pursuit of mastery over the skies. As the aircraft continued its course, the echoes of that ghostly speed lingered, a reminder that in the realm of flight, certainty is often an illusion, and vigilance remains the pilot's most indispensable companion. Fingers dance across the multifunction control display unit, the nerve center of communication with the flight management computer. A desperate attempt to reboot the speed control mode unfolds. The autopilot blinks off, then back on, a flicker of hope against the digital glitch haunting the system. 3 seasoned crew members, eyes locked on the glowing screen, search for a fault hidden deep within lines of code, blind to the catastrophe quietly gathering beneath their fingertips. Suddenly, the night's silence shatters. A stark white light blazes across the display, an overspeed warning, its arrow plunging downward. Simultaneously, a piercing alarm screams through the cockpit, signaling a dangerous breach. The leading-edge slats are extended beyond safe limits at cruise velocity. These slats, delicate movable panels along the wing's front edge, serve only during takeoff and landing, allowing the aircraft to maintain lift at slow speeds without stalling. At cruising speeds exceeding 80 knots, their deployment is akin to flying with brakes locked, an invitation to disaster. In that instant, control slips away. The massive MD-11 pitches violently upward, as if seized by an invisible hand. Pilot. The autopilot, overwhelmed by the sudden aerodynamic upheaval, disengages. Commander Lu Zanpin yanks the control yoke, striving to level the aircraft, but confronts the MD-11's notorious sensitivity, a craft as light on controls as it is unforgiving. Uncontrolled oscillations erupt as the pilot's frantic inputs clash with the machine's delicate balance. In a desperate bid to counter the aggressive pitch, the commander pulls the yoke back too forcefully. The plane, inherently unstable longitudinally, responds with a bring. The G-forces swing from crushing positive overloads to near weightlessness, plunging into negative 1.24 G. Imagine that. One moment weighed down by half your body's mass, the next flung upward with a force that slams you against the cabin ceiling. Inside the cockpit, alarms scream louder. Angle of attack indicators flash warnings of an imminent stall, while the stick shaker vibrates the control column, a desperate tactile plea. A wing is about to fail. The onboard engineer, Lu Lianxin, senses the root cause, the leading-edge slats lever. Twice, he struggles to keep it retracted, but the damage is done. The aircraft has already crossed the threshold into chaos. This is no ordinary malfunction. It is a brutal ballet of machine and human, a deadly interplay of fragile aerodynamics and split-second decisions. The MD-11's delicate equilibrium shattered, the crew wrestles against forces that defy control, their every move amplified by the aircraft's mercurial nature. The night sky outside remains indifferent as the giant hurtles through a nightmare of its own making, a stark reminder that in the cockpit, mastery over metal and code is both a science and an art, one that can unravel in a heartbeat. The aircraft trembled violently, its own control surfaces spiraling into resonance, turning the cockpit into a battlefield of wills. Amid this relentless struggle for command, the passenger cabin transformed into a scene of pure chaos. The seatbelt warning had been silenced, leaving the occupants unprepared for the sudden assault of forces. As the plane endured a negative G-force exceeding 1.24 times gravity, unsecured passengers were flung skyward, colliding with the ceiling in brutal impact. Witnesses later recounted a terrifying tableau. Carts laden with meals and luggage suspended mid-air, careening uncontrollably through the cabin. Heads struck the overhead panels with such force that bodies convulsed from the blows. Some passengers pierced the decorative ceiling panels, becoming ensnared within the aircraft's internal framework. Heavy seats, never engineered to withstand such stress, were torn from the floor, twisting and breaking free in the violent turbulence. After several harrowing cycles of these oscillations, Captain Lu Zanpin wrested control back from the chaos. The cabin, once a place of refuge, resembled a war zone. Blood coated shattered plastic shards, mingling with muffled groans of the injured. 2 passengers succumbed instantly, their skulls crushed beyond survival. Over 60 more endured grave injuries, broken bones, fractured spines, and open wounds festering amid the wreckage. Among the crew of 20, 12 bore injuries of varying severity. The cockpit lay buried beneath a pile of interior debris, dust from shattered insulation lingering the cockpit. Captain Anpin grasped the dire reality. The aircraft was critically damaged, the injured urgently needing medical aid. Yet they were stranded over the vast Arctic expanse, thousands of kilometers from the nearest land. Salvation hinged on a fragile thread, a tiny strip of Earth known as Svalbard, the remote airbase of Svalbard. This 4-kilometer-long island, buffeted by icy Arctic, crippled plain. But landing was no simple matter. Svalbard was a restricted United States military installation requiring clearance from Washington itself. The US government, wary of the unexpected arrival, initially viewed the aircraft with suspicion. Could this be espionage cloaked in tragedy? Only after confirmation of the wounded passenger count did the Pentagon grant permission for emergency landing. At 1 hour 23 minutes local time, the crew signaled their intent to descend. American military controllers, upon hearing of the Chinese airliner's plight and the multitude of casualties aboard, immediately placed the base on full alert. The approach and landing of the heavy MD-11 on the Svalbard airbase became a feat of precision and nerve. To reduce the landing weight, pilots were forced to jettison fuel, knowing that excess kerosene could jeopardize the compromised landing gear. A single misstep might cause the weakened struts to collapse, igniting a catastrophic fire. In the pitch-black Arctic night, every second stretched taut with tension. The fragile aircraft, bearing the scars of its ordeal and the weight of human suffering, descended towards a narrow strip of frozen earth, a beacon of hope amidst the merciless wilderness. This desperate flight, from chaos to sanctuary, etched itself into memory, a testament to human resilience and the fragile threads that bind survival to fate. A colossal aircraft, guided by the precision of the instrument landing system along the subtle arc of a narrow runway, approached its final descent. At precisely 3 hours and 29 minutes, its wheels kissed the concrete with a delicate yet resolute grace. The engines fell silent, surrendering to a profound stillness that was instantly shattered by the piercing sirens of American rescuers. That night marked the definitive end of the Cold War's shadow. American medics and military personnel, driven by unwavering courage, rushed to save Chinese civilians on a covert airbase hidden from the world's gaze. Investigators from the United States National Transportation Safety Board arrived on the island after the injured had already been evacuated to a hospital in Anchorage. They faced an immediate obstacle. The flight data recorder was flawed. A critical portion of information had been lost due to a malfunction in the data acquisition unit. Yet, the silent testimony of the cockpit spoke louder than missing figures. Their focus narrowed on the flap and slat control lever, an unassuming mechanism that held the key to the unfolding tragedy. Experts settled into the pilot's seat, reconstructing the atmosphere of that fateful night with painstaking attention. The revelation was staggering. The lever on the McDonnell Douglas MD-11 was designed with such a fatal flaw that a mere brush of an elbow, or even the sweep of a broad uniform sleeve, could dislodge it from its lock. Commander Ludzan Pin, while inputting data into the flight computer, inadvertently nudged this lever. This slight, unintended motion caused the slats to deploy at an altitude of 10,000 meters, an altitude where such movement was perilous. Yet the catastrophe was not born solely from ergonomic missteps. It was rooted deeper in the very philosophy behind the MD-11's design. In pursuit of fuel efficiency, engineers sacrificed inherent aerodynamic stability in pitch. To compensate, the aircraft was equipped with the Land Longitudinal Stability Augmentation System, or LSAS, an electronic guardian tirelessly correcting the plane's balance, easing the pilot's burden. At cruising altitude and velocity, this system transformed the MD-11 into a delicate, unstable instrument. When the slats extended unexpectedly, LSAS and the autopilot fought desperately to counteract the sudden pitch changes. Their efforts, however, were overwhelmed. As control returned to Commander Pin, his instinctive reaction was to push the yoke forward sharply. This triggered an overzealous response from the hypersensitive LSAS, igniting a destructive feedback loop, a classic resonance between man and machine spiraling beyond control. One might wonder why the pilots did not simply retract the slats to regain stability. The answer lies within the wing's intricate logic. On the MD-11, slats deploy in a precise sequence, inner sections before the outer. Once the outer sections began their extension, The system locked out any commands to retract until the entire cycle completed. This safeguard, intended to ensure aerodynamic integrity, instead sealed the fate of the flight. This event stands as a stark reminder of how the pursuit of technological advancement, when coupled with human factors overlooked, can converge into disaster. A flawed lever, an overcompensating stability system, and the unforgiving laws of aerodynamics combined to create a moment where control slight, but the closing chapter of an era defined by division and mistrust, replaced by a fragile, shared humanity bound by tragedy. The mechanical brain of the aircraft had already taken control, overriding the desperate attempts of Commander Ludzan Pin and flight engineer Lulian Sin to return the lever to its safe position. The plane's nose continued to pitch upward, defying human will. A cascade of factors, a flawed lever design, a faulty control logic, and the unforgiving laws of aerodynamics converged high above the vast Pacific Ocean. This incident marked a turning point in aviation history. It revealed that human error extended beyond pilot mistakes to include design failures that misled those at the controls. In response, the National Transportation Safety Board issued sweeping recommendations. All operational McDonnell Douglas MD-11s were fitted with protective barriers around the leading-edge flap levers, while the shape of the locks was redesigned to prevent accidental movement. Airlines worldwide integrated rigorous simulator training for pilots, emphasizing smooth recovery techniques from complex spatial disorientations at high altitude rather than futile resistance against the aircraft's behavior. Passenger seat anchoring standards and ceiling panel strength requirements were also overhauled. Despite enduring severe damage, Board Bravo 2171 was painstakingly restored and returned to service for many more years, retiring only in 2014. The echoes of this event continue to shape aviation safety, a testament to lessons forged in the skies where human ingenuity meets machine fallibility.